Welcome to Center of Math's Advanced Knowledge Problem of the Week. For this week's problem, we're given a connected graph with q edges and p vertices, and that q equals p minus 1, and we want to show this graph is a tree. We're going to use the easy-to-prove fact that if q equals p minus 1 in a connected graph, then the graph is a tree, and we want to prove the other way. So this is a necessary and sufficient condition for a connected graph to be a tree. So we're going to take some graph. So a tree is a graph that does not contain any cycles, that's connected and does not contain any cycles. So there's only one path between any two vertices. So taking any graph, say it satisfies q edges, p vertices, and q equals p minus 1. And let's also assume the graph has cycles, so it's not a tree. And so we're going to proceed by, for every cycle in the tree, we're going to pick any cycle. We're going to remove an edge from that cycle. Note that the graph is still connected. Since the cycle, there are two paths between any of the vertices, so you can still get from any verse to any other verse. So we'll keep removing our edges until we have no more cycles. And since the graph is still connected, it has no cycles, it is a tree. And so using our theorem, then we know our modified q, which since upon removing all our cycles, we're left with q equals p minus q modified equals p minus 1 in our newly made tree. But we know this q modified, we assume we had some cycles, so we assume we removed some edges. So q prime is going to be strictly less than q, which we assume is equal to p minus 1. And so we have p minus 1 is less than p minus 1, which is a contradiction. So we must not have any cycles, and so our graph must be a tree. Thanks for watching. Please check out centerofmath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.